And we are live here Thursday, May 4th. May the 4th be with you and also with you. Yes, and here we are, Bell Work Day 11. Here's the problem. We have 16 unlabeled bottles on the table. 10 of them are filled with Coca-Cola, 6 of them are filled with Pepsi. You're picking one bottle, putting it back, and then selecting another. Determine the probability of selecting two Pepsi bottles. Two Pepsi bottles. Is anybody going to be bold and offer me an expression of how they did this? How many draws do I have? Do you know what I mean by draws? What do you think, Diana? How many draws do I have?
Like chances?
Yeah. 6 out of what? 6 out of 16. What do you guys think of that for the first draw? Thumbs up, thumbs sideways, that's easy for me to say, or thumbs down. I don't see any thumbs. Come on, people. What, are you thumbless today? What do you think? I see 2 thumbs up. 3. Put your thumb up, she says. Yes, that is right. We are talking about Pepsi, and we have 6 Pepsis. So initially I was asking how many draws. There are 2 draws that we're looking at, okay? But 6 out of 16 is correct for the first probability. All right, what about putting that Pepsi bottle back and on the second draw, selecting another Pepsi bottle? What is that probability going to be? Leslie, what do you think?
Can you repeat the question? My bad.
No, yeah, I can repeat it. So if we put whatever we got from the first draw, we put it back in line with the other drinks, okay? What's the probability that I am going to pick Pepsi on this second draw?
Is it like the same if you put it back anyways, or is it like 5/16?
Well, is that the same, or do you want it 5/16?
I'll just go with 5/16.
5/16. All right, what do you guys think of that answer? I'm getting shakes of the head and some down. Why do you think it's not 5/16? Anybody? Yeah, you put the first bottle back. You don't know if it was Pepsi or Coke unless you break it open and drink it, right? So the probability of the second one is still going to be 6 out of 16. Okay? Because it looks like the original. Leslie, does that make sense?
Yeah.
Are you sure? Okay. So, my final probability then, multiply your numerators together, get 36, multiply your denominators together. 16 times 16 is 256. Anybody have that answer? Yes, good. Bless you. Anybody else? You know, isn't that bad when you sneeze? You're trying to be polite and not sneeze all over, but then it hurts. Did that hurt kind of? A little bit? I hate that. You know? I know. We talk about all kinds of things in here. All right, let's take a look at the second problem. What is the probability of selecting one Pepsi followed by one Coca-Cola? So I have 2 draws here. Okay? Melvin.
Yeah, what's up?
What's up? What's my probability for selecting a Pepsi on the first draw of the second problem? Remember, probability is successes over the total. Pepsi. Okay, is that your answer?
Yeah.
Are you sure?
Positive.
Okay, what do you guys think of 6 out of 16? I got thumbs up, thumbs down, thumbs up, thumbs down. Why thumbs down? Say it again.
You got one extra Pepsi.
We have an extra Pepsi?
There's one Pepsi.
Right. But for selecting that Pepsi, how many do we have that are Pepsi? In other words, yes, we are picking one Pepsi, but the probability that I select it is how many I have out of the total. So it should be just like selecting a Pepsi over here for that first draw only, though. That's not the final answer. Okay? So it should be 6 out of 16 because I have 6 Pepsis out of the total of 16. Okay? Good job, Melvin. All right. Now, what's the probability of selecting a Coca-Cola? And remember, we put the bottle back. Moses, what did I get for my second draw?
10 out of 16.
10 out of 16. What do you guys think of that? Thumbs up, thumbs up, thumbs up. Yes, shake the head. Yes, good answer, good answer. All right, does everybody understand? Because we have 10 Coca-Colas. 6 times 10 is 60, and 16 times 16 is 256. All right. So you have a higher chance of picking a Pepsi, putting it back, and then getting a Coca-Cola than what you do of 2 Pepsis. Any questions on that? All right, here we go. Number 2, permutation or combination. Medical researcher needs 6 people to test the effectiveness of an experimental drug. If 13 people have volunteered, how many ways can 6 people be selected? What do you think, studio audience? Is it permutation or combination? Say it again. Permutation. Who says permutation? I can't hear. All I heard is permutation, and they both end in that. What do you say, Diana? Permutation. What do you say, Kennedy?
Honestly forgot the difference between the two. Like, I know what they both mean, but like, I forgot.
Okay, so there's an I don't know. What do you think? Combination. What do you think? Permutation. Leslie.
I'm gonna go with combination.
You're going to go combination. What do you think, Melvin? Studio audience? Come on, we got a time limit.
Both.
Both. Okay. All right, Quinasia, what do you think?
I'm not sure. I'm just gonna say combination.
Combination, Miranda? Combination, Moses?
I don't know.
I don't know. Oh my gosh. Okay, the correct answer has been given. Of course, there were 4 different answers given. You are supposed to remember pom-poms. And pom-poms, it helps you remember that in permutation, order matters. Now, does order matter if we're talking about 6 people volunteering? Not really. Yeah, it's an experiment, but we don't care. You know, just as long as I have 6 people, I don't care that you are the first one and you are the second and blah, blah, blah. So I'm going to say that this is a combination. Order is not important. Combination, order, not important. And how do we do that? I know it's been a while. Somebody want to get the door? So we have 13 people for a combination looking at 6 at a time. Okay? If you do that on your calculator, do you remember how to do that on the calculator? You put 13 in first, Then you hit PRB. And you go down to combination and then 6. And what do we get for an answer? 16?
Yeah, 1,000.
Yes, very good. Okay. So all we need is 6 people to test the effectiveness. We don't need to know the order. So good job, those of you that picked combination. Those of you that picked permutation, again, permutation is when order matters. Melvin, you can't have both at the same time. Nice try, though. Okay.
It's possible.
It's possible. I don't know about that.
Nothing's impossible.
Any questions on these two? Boy, we've taken up a lot of time. All right, let's jump to the notes now on page 19. Page 19. We have another table. Not the food kind, though. Hopefully you had some good breakfast. All right, so on page 19, talking about a sample of boys and girls at Guyan Creek Middle School was taken. The results are displayed in the two-way table. And as I understand it, you do not have the words again. So the first column is cats. The second column of numbers is dogs. The last column is total. Not the cereal, though. And in the first row, we have boys. And if we have boys, you'll never guess what we have in the second row. Very good, girls. And in the last row, we have, again, total. All right. I am going to give you 2 minutes tops to do 1A, B, C, and D. Ready, set, go. A, B, C, and D. Everybody. I think you can do it.
What about the ones that don't have any pets?
Don't have what?
Any pets?
This might be what they prefer. Not that they actually have them. It doesn't really actually say. So we'll say what they prefer to have or what they like best. But I understand what you're saying totally. Okay. Just over a minute left. All I'm asking for you to do is A through D. If you want to go ahead and try the rest, you may. I do have a mistake on my notes. Those of you that have my notes or have looked on my notes on Canvas. Okay, 30 seconds. Kennedy, do you have them all done? Nice. Fifteen seconds. So quiet. All right, here we go. 1A, what is the probability of selecting a boy out of this table? Who feels pretty confident in their answer? All right, Denham, give it to me. 100 out of 152. How do you guys feel about that? Survey says, yes, you are correct. You have won a new dishwasher. How exciting, huh? New dishwasher. All right. Letter B. What's the probability of selecting girls then? 52 out of what?
I mean, 152.
Very good. Very good. What do you guys feel about that? Survey says
No.
no. Ooh, dissent within the class. Why do you say no?
Because why not?
Because why not? Well, we're on a time limit here for our show, mister. So it is correct. Yes. 52 out of 152. Even if we didn't have the table, if you knew the boys were 100 out of 52, the girls would have to make up the other part of that, which would be 52 out of 152. How many had both of those? You are terrific. All right, here we go. What's the probability that these students like cats? 73 over 152. You have won a new Singer sewing machine. No point. Okay. Yes, very good. 73. How did he get that? He's looking at all the cats, finding the total of the cats, and putting it over the total. All right, here we go. 4 for 4. Can we do it? Who wants to give me the probability of selecting or someone selecting or liking dogs? Somebody I haven't talked to yet. 79 over 152. That is correct. You get a brand new trip to the junkyard. Woohoo! No, kidding. Huh? What? No, just as much as getting a sewing machine or a new dishwasher. Why, you want to trade? You want to keep the sewing machine? Okay. I was trying to think of a trip somewhere. I guess I should have said to the library over here beside the school. All right. Good job. 4 for 4. Nice. All right. Letter E. This is where they start to get a little tougher. So this says the probability that someone likes cats, given that, there's that vertical line, given that they are a girl. Those given that statements are going to have different denominators. So what's my denominator here, Austin? 52. He was very quick and confident about that, and he is correct. Yes. So if I'm looking at all girls, that is this row right here, and I want the ones who like cats. So I look at all the cats, and what's my numerator going to be? Not 73. It has to be 52. It has to be a girl. Has to be a girl who likes cats. So that's where they intersect. Yes. Why can't it be 73? There's a couple of reasons. It would be over 1 then, right? And we know all probabilities go from 0 to 1. And it said we were only looking at the girls. So the 32 would be boys who like cats. Okay? Good, good. Nice job. Letter F. Letter F says, what's the probability? Oh, actually, you tell me. Is that an and statement or an or? Or. Yes, it is an or. That's the for the union. And for the union has the word or in it. If we're for the union, we want everyone to join the union. We want all cats. Plus, we want all boys. But we don't want to count the cats or the boys who have or like cats twice. So we have to subtract the cats and the boys together, the intersection. So the probability of all cats, what's that numerator? 73 plus the probability of all boys, 100, minus Probability of cats and boys, the intersection.
32.
What'd you say?
32.
32, yes. Minus 32. So we say 73 plus 100 is 173 minus the 32, because we don't want to count the boys who prefer cats twice. And, oh, that's 432. That'd be 141. What is my denominator? Leslie, what's my denominator?
Hold on, I'm still writing down.
Okay. Kennedy, what's my denominator? Come on, you got this. Is it a conditional statement?
Is C or B?
It is C or B. We're on letter F, yes. You got 152. You're lucky. The time was almost running out. Yes, 141 over 152. Any questions on how to get that? So, Leslie, you look beautiful. All right, letter G. Letter G. What's the probability of someone liking a dog given that they are a boy? Let's go to Miranda. Dun, dun, dun. Letter G. What is my denominator? She says 100. What do you guys think about that? Thumbs up. That is correct. We have to look at all the boys. And what's my numerator? Who haven't I talked to? It's a small crowd today. Melvin. Melvin. What's the probability of someone liking dogs given that they're a boy? Given that they're a boy, that they like dogs. It's on your paper also.
I think it's 11. Oh, 68.
11 out of 68. We already determined it's out of 100.
That's a joke. It's 68.
That was a joke? That's a bad joke.
It's a very funny one.
68 out of 100. That is correct. 68 out of 100. Questions on that, Melvin? Do you understand why?
No.
Do you want to understand why? Okay. Good. I'm glad you said yes. You need to look at all boys. All boys for the conditional is 100. And dogs or boys who like dogs or prefer dogs is where they intersect right here. Okay. Let's go to the last one. What's the probability of selecting boys and those who like dogs? Boys and those who like dogs. And you're like, well, isn't that kind of the same thing we just did? What do you think? I'm sorry, I can't hear that.
68 out of 152.
Yes, 68. It is the same numerator because it's the intersection of boys and dogs right here, but it's not conditional, so it's over 152. Any questions on any of those 8? Guys, please put the phones away. Come on. All right, number 2. Let's jump to number 2. If this is a random sample, what total percent of boys do you think would prefer dogs? If this is a random sample, what total percent of boys? So are we looking at the whole population? Are we looking at boys or are we looking at girls? We're looking only at the boys. How many boys do we have? We have 100. So that is going to be your denominator. And what percent of those boys do you think prefer dogs? 68. So this kind of goes with letter G, 68 out of 100. What does percent mean? Means out of 100. So if you put this on the calculator, 68 divided by 100 is 0.68. And then if you change that into a percentage, it's 68%. And yes, you could go directly from this to 68%. Okay. All right. What percent of students at the school would prefer cats? What is my denominator there? What percent of students prefer cats? What am I taking it out of, first of all?
73.
Say it louder.
73 from the total.
Not for the total. Well, total of what?
Boys and girls who like cats.
That is boys and girls who likes cats. Where would that go in my probability? Is that it says what percent of students like or prefer cats?
48%.
Okay, well, we got to figure out the probability first.
Oh.
So 73 is a correct answer. And that is boys and girls who like cats. Is that the numerator or denominator, you think? Or do you want to phone a friend? It is the numerator. You are correct. So it is 73 out of how many? 152. And if you do that on your calculator, you're going to get about what? 0.48 something? And change that to a percent is 48%. Questions on that? If you sampled a different 152 students, would you get the same percentages? No, not necessarily. Okay, not necessarily, because all kids are different and people have different preferences. So not necessarily students have different preferences. Okay. I would say I prefer dogs over cats, but Mrs. Tomaszewski or Mrs. Bolton over here maybe prefer something else. Okay. All right. Number 5, last one. What would happen to our percentages if we used a larger sample size? So right now, my sample is 152 students. If we used a larger sample size, what would happen to my percentages? Would go lower? Why do you say that?
Because it's more, a larger sample is more students.
There is more students, definitely, yes. That doesn't necessarily mean it would go lower. Doesn't necessarily mean it would go higher either. Anybody else? I'm going to say the percentages, I'm going to say would be similar or very close. Okay? Usually when you have a sample size that's small like this, it is usually pretty representative of how people feel in general. Not always, but usually. So I would think the percentages would be similar. So yes, you will have more people, but you probably will also have more people who slightly prefer dogs over cats. Okay? That would be my thinking. So I think they would be similar. And that's all I had to say about that. All right. I think we are going to stop there. So tomorrow we do have a skills check. I do think I am going to put it on paper. You should have homework 7-3. You should try to finish that up in preparation for the skills check. Also, make sure you have homework 7-1 and 7-2 done. If you have any late or missing homework, please get it to me tomorrow so I can grade over the weekend. And it probably would be a good idea to look over the bell work and your notes in preparation. I believe this is 25 points and it is a homework grade. Yes, Caden. I honestly did not look for it. 6-4, is that the surface area one? Okay. Okay. And I didn't give it back, and there's no grade. Okay. Any questions on anything we've done?